Hi, my name is Suman Chetri. My student ID is 21557870. Today we're presenting this video for assignment 1 in advanced topics in software engineering module. The topic of this presentation is deep learning neural network and their impact on software engineering. Reasons to select these topics are deep learning and neural networks have been revolutionizing the field of machine learning and artificial intelligence were quite popular in this current context. These technologies can also help us to create more effective and efficient software engineering that can handle large amount of data which are being produced in every minutes and seconds. As a software engineer, it's essential to understand these technologies, its potential impact on our work, both now and in future. In this presentation, we will discuss about deep learning and neural networks and its impacts and challenges while implementing on field of software engineering. We will also provide some real-world examples of how these technologies are being used. We will also discuss about future directions, and we will critically analyze and we will present our discussion, which includes evaluation of work. Methodologies used in this research are systematic literature review, comparative study, case study, and bibliometric study. We were mainly focused on systematic literature review, which includes analysis and summarization of scholarly articles, books, and other sources that are relevant to these topics, and evaluation of sources for the relevance and quality and credibility, and arrangement of gathered information to identify key trends, themes, and gaps in the existing research.
Hi, I am Soumya Sundar Rana. My student ID is 21557919. I'm going to talk about deep learning and neural networks. So what is deep learning? Deep learning is a subfield of machine learning. It involves training artificial neural networks with multiple layers. It is based on the idea of learning multiple levels of representation. And what is neural network? It is a widely used machine learning algorithm. It is modeled after the structure and function of the human brain. It is designed to recognize patterns and relationships in data. It consists of layers of interconnected nodes. So how does deep learning work? Deep learning models are frequently referred to as deep neural networks because most deep learning techniques use neural network architectures, large sets of data, which is used along with the neural network architecture, so there is no need for manual feature extractions. The deep networks can have as many as 150 layers, while the traditional neural networks have only 2 to 3. So some of the areas that neural networks are applied in software engineering are software quality assurance, software testing, maintaining security, image and video analysis, and speech recognition. The impacts of neural networks in software engineering are it has the ability for predictive maintenance, it enhances software quality, it reduces costs, it helps in natural language processing, and it helps in computer vision as well.
I'm Slow Vimal. My student ID is 21523328. I'm going to talk about application of neural networks in software security. As published by IEE, the design of software is 50% the reason that software is vulnerable these days. Therefore, designing a software with security in mind will go a long way in developing a secure software under which architectural risk analysis falls. Architectural risk analysis is used to identify vulnerabilities and threats at the design phase of SDLC, which may be malicious or non-malicious in nature due to a software system. Different type of automated testing can be done using the neural network, and we can use neural network to know the behaviors of previous malware and train it to predict or guess the new upcoming malwares. We can do vulnerability scanning too. After fault prediction, we can use few techniques to carry out using logistic regression, discriminant analysis, and artificial neural network. For predictive modeling, deep learning models can be trained on large data sets of software code to predict the likelihood of fault occurring. For anomaly detection, deep learning model can be used to detect anomalies in software code that might indicate a fault. For transfer learning, different kind of train techniques that was used previously uh, can be transferred to learn about the new models and all. For code analysis, neural network can be used to analyze the code that we made.
This is Amit Tiwari. My student ID is 2156351 and I'm going to talk about the convolutional neural network and how it is being used in the automated vehicles. So CNN is a network architecture for deep learning that learns directly from data, and it is used for finding pattern in images to recognize object classes and categories. They can also be quite effective for classifying audio, time series, and signal data. There are numerous variants of CNN, however, their basic components are very similar. Taking the famous LN85 as an example, it consists of three types of layers, namely convolutional, pooling, and fully connected layers. So I went through research articles on the use of CNN in automated vehicles, which suggested the recent developments in deep learning techniques for autonomous vehicles, including CNN-based object detection, lane detection, and pedestrian detection. Overall, these studies demonstrate the significant potential of CNNs in the context of automated vehicles, but also highlight the need for further research and development to overcome the challenges associated with the real-world development. Further talk about the CNN architecture. The first image shows the CNN architecture, how the raw image is processed through convolutional and polling to create an accurate outcome. So the hidden layers has tens and hundreds of layers to provide an accurate outcomes. And similarly, the second image is from the HydroNet by Tesla. So HydroNet is dynamic architecture, so it can have different CNN networks, each assigned to different tasks. These blocks of networks are called branches. The idea of HydroNet is to get various input and feed them into a task-specific CNN network. Like take the context of self-driving cars. One input of dataset can be of static environments like trees and road railing. Another can be of the road and lanes, and another of traffic lights and road, and so on. So these inputs are trained in different branches. During the inference time, the gate chooses which branches to run, and the combiner aggregates branch outputs and make a final decision. So the Tesla can also create a bird eye view of the surrounding environment for more accurate detection. The autonomous vehicles is still a new concept, and there are a lot of challenges associated with real-world deployment of CNNs in automated vehicles, such as limited data, as CNN requires large amount of data, and the adverse weather and lightning conditions such as rain, fog, and darkness can degrade the performance of CNNs. And generalization, CNNs trained on one set of data may not perform well on different set of data, and it also requires intensive and amount of computational requirement, and also the safety and reliability. So the recent research shows that attitude towards autonomous cars have taken a turn for the worse. For instance, a survey by AAA found that 68% of Americans fear the technology, which is an increment of 13% from last year. So overall, addressing these challenges is critical for the successful deployment of CNNs in automated vehicles, and ongoing research and development is needed to overcome these obstacles.
Hello, my name is Suman Dungana and my student ID is 21559565, and I am going to talk about challenges and future directions in applying neural network. So there are several challenges of neural network in software engineering, like there is limited data in common challenges in deep learning, interpretability in another challenges in deep learning. Also there is overlifting is well-known challenges in deep learning. Scalability is also challenges in deep learning. And also we can find like neural network requires a significant expertise and research to develop and deploy, limit adoption and uses. So I'm going to further talk about the future of deep learning. Deep learning models can be trained to generate code which could potentially save developers time and efforts. Similarly, bug detection, predictive analytics, and deep learning can be used to optimize software systems, such as improving performance or reducing memory uses. The future of neural network are similar to deep learning, such as automated testing, code analysis, explainability, security, and natural language processing.
Hello, this is Sulal Vimal again, and I'm going to uh, talk about critical analysis, and we're going to make different discussion. We're going to talk about how this research can be improved. We can conduct different case studies, do different observational research, and we can have like different surveys and all. We can also experiment with our research. We're going to talk about few things that we can discuss, like software system is changing day by day rapidly, so like we need to get updated with it. It is difficult to obtain high quality data for our training. There is always a risk of overfitting the model. It's like really hard to find the root cause of all, and it's important to critically evaluate and discuss the research. Thank you.